Hi there. So obviously there's no bigger topic in the world at the moment than COVID-19 or the novel coronavirus. And you will have seen a lot of articles in the news and probably maps popping up showing current numbers of cases, death rates, all that kind of information. But if you're like me, one of the things that you're probably thinking or wanting to do is how can I delve into the data myself and get a better understanding of what's going on and make my own visualizations to get to grips with this global crisis. So in this video, I'm just going to quite quickly and hopefully simply show you how to produce maps of cases and deaths related to coronavirus using the free QGIS open source GIS software. So hopefully by the end of it, you'll be able to create something like this, where we either have country polygons coloured by cases or death rates, or the point maps that have been so common also in the news recently. So we're going to start with a blank canvas, start a new project in QGIS, and obviously the first thing we need to do is get hold of some data. So if we open up our browser, we're basically going to get two data sets. The first of those is a global map, just a shapefile layer of country boundaries, which we can then use to join the coronavirus data to and provide a base map, as well as visualizing it by coloring our polygons. And we're going to get that from Natural Earth data. So Natural Earth data is an amazing source of free base map data. It's worth exploring. They have various data sets here designed for kind of large scale global mapping down to kind of country level mapping. So if we go to naturalearthdata.com, go to the download section, and I'm going to go for the medium scale data and go for cultural because I'm interested in countries, and I'm just going to download the admin 0 country level data without boundary lakes. So click here to download it. It will download as a zip file, so you'll need to open the zip file. If you're using Windows, it should open automatically, and then the easiest thing to do is literally shift click to select all of those layers, copy them and paste them into the folder that you're going to be working with. So in my case, I'm going in data, COVID-19, world map, and I've actually done this already, so I'm not going to paste a new version in. I experimented with the 1 to 110 million scale map. That was a bit too coarse for my liking, which is why I've decided to go with the 1 to 50 million version. So that's where we get our base map, pretty straightforward. We can then go into QGIS, browse to our folder, find the world map folder, and drag in. So we want the 1 to 50 million file, 50M, and the .shp file is the one that's going to load the world map. So there we go, we've got our base map. Obviously, the next question is, where do we get our COVID-19 case data from? So the best source that I've found is this source here on Github. So this is a repository created by Johns Hopkins University in the United States, and they've pulled together data from a whole range of different sources to try and get as accurate and up-to-date as possible a global picture of coronavirus cases, coronavirus deaths, and recovery rates. So you can see the link up here, but I'll also obviously paste that in the text underneath the video so you can find the link there as well. So once you're at the repository, we're going to go into the CSSE COVID-19 data folder, and then the time series data. And there's a couple of different files in here, so I'm going to focus on the global cases for now. So, but you can do exactly the same process with global deaths and global recoveries, or if you want US specific data. So I'm going to click into the time series COVID-19 confirmed global CSV. And then to be able to actually download the CSV file, I'm going to change it to raw. And you'll get a screen full of numbers, but if we just right click here and go save as, then this gives us our COVID-19 dataset. And again, we can browse to wherever we want to save this. Now, I've got a previous version, so I'm just going to add new on the end here and click save. So there we go. We now have a CSV file containing COVID-19 case data. And if we go back to the previous page, we can see that conveniently it also provides latitude and longitude coordinates for each of the countries or territories that it covers. So actually, we should be able to add this into GIS pretty easily. So to do that, the best way to add a CSV file into QGIS is always to use the data manager, or data source manager, sorry, rather than dragging and dropping. The reason for that is that if we add it via the data source manager, it will correctly identify columns that contain numeric values. If you drag and drop, it tends to just parse everything as text, which can then cause problems further down the line when we want to do a little bit of manipulation and visualization of the data. So always add the CSV file using the data source manager. So we can browse here. And I'm actually going to use one that I downloaded yesterday and added a few extra columns for. I'll mention that in a minute, but we don't need to worry too much. It doesn't actually affect the process in terms of producing our basic map. So select your CSV file, click open. So under geometry, we have point coordinates. It should pick that up automatically. We will need to tell it our X and Y fields because it doesn't seem to detect those automatically. So our X field is longitude. That's our east-west coordinate. Our Y field is latitude. That's our north-south coordinate. And our CRS is 4326. So that's our coordinate system. We're in latitude, longitude, WGS 84 coordinates. And once you've selected those, you can simply press add. And voila, we now have a point layer in our data set ready to visualize. Now at the moment, this is what they call a scratch layer. It's temporary. If we close the map, we'll lose it. If you want to save that as a permanent point layer, simply right click, go to export, save features as, and you can choose a format, whether you prefer shapefile, geopackage. If you want to change the coordinate system, you can do, and simply browse to where you want to save it. And you can see I've done this previously, named it cases. Let's call this one cases new, and click OK. And we've now got that added to our map as a permanent layer. We can remove the original one. So how do we then visualize this? So the simplest way, and as I said, the approach that I've seen a lot in papers and magazines, is to simply visualize these points using different sizes. So if we right click, sorry, I went through that a bit quickly, right click on our point layer, go into properties, and under the symbology tab, we want to change from single symbol to graduated. So this allows us to vary how our point is displayed according to a value. The first thing we want to do is select a column, and you can see we have these date columns. The modification that I made is I actually worked out, in addition to just the dates, actually daily percentages, so essentially what percentage of global cases each country has that particular day. But actually, because yours will just have at the moment the daily cases, I'm going to select the last one in the version I downloaded, which was the 19th of April. And I'm then going to change my method from color to size. And I'm actually going to click here to change my point style. I'm going to change that to a red point. So what we're going to have is red points, which are scaled, the size adjusted to indicate how many cases were in each country or territory on that day. And I'm actually going to increase that slightly, size from 1 to, let's try 12 for now. And you can play around with the mode here. You'll get slightly different, if I just click classify, so I'm going to leave it with 5 classes, click apply, and okay, we can see it's now scaled those. It looks a bit messy at the moment. You can play around with the mode, you'll get different results. Natural breaks tends to work reasonably well in terms of highlighting which countries are standing out with the highest numbers of cases. You can see around Europe, United States, Wuhan over here. But personally, I'm not the biggest fan of these kind of scaled point maps. I find them quite hard to interpret. There's a lot going on. So what I prefer to do is actually link this data to the country outlines and visualize it by colouring each country according to the number of cases. So what I'm going to do first of all, because this world map is going to kind of become our base layer, and one thing it will end up doing is colouring in any countries for which there's no data available. So I'm actually going to go into properties for that and change it just quickly to the grey fill. So what that means is when I layer other data over the top, this will provide a kind of grey background for any countries which don't have data of their own. So before I go into the next step, one thing to note is that obviously some countries have multiple points. So a lot of countries just have a single record. How many cases per day in the United Kingdom, France. But some countries, Canada and China in particular, have their data according to territories, and also Australia by the looks of it as well. So we need a way that we can actually sum together all of those values within each country so that we can visualize that with a single value. And luckily, there is a tool within QGIS that allows us to do just that. But it doesn't appear under the normal menus. If we go to Vector and Data Management Tools, we have this Join Attributes by Location, which almost does what we want, but actually only allows us to link one point. So what we need to do is go to Processing, Toolbox, and search Join. Let me type it in again. And what we actually need is Join Attributes by Location, brackets summary. And what this allows us to do is actually, if we have multiple points within one area, it allows us to calculate summaries. We can add them together, we can calculate averages. So it's actually useful for a whole range of tasks. So in this case, our input layer is going to be our country outlines, which is this one here, NE50M admin. And our join layer is going to be our point layer. So because all of our points should be within the areas, leaving it as intersects, the default is fine. And the fields we want to summarize, I'm actually going to select all of the ones that contain case information, which is essentially everything except for these first 4 columns which contain information on the location. So the easiest way to do that is to select all and then just untick those first 4 columns. Okay, and then we have the summaries to calculate, and you can see here the range of statistics that we can calculate. So for what we're doing right now, the only one we actually need is sum. So we simply want to add together all of the values for points contained within that particular country polygon. So sum, okay, and we can then we have the option to discard results which have no data. I'm not going to worry about that. I'm going to keep those outlines, although they will kind of get hidden when I display the data anyway. And then we can set where we want the output to be saved to. So I'm going to call this cases polygon. And again, I've got that set to save as a shapefile. You can pick your preferred data format if you're not a fan of shapefiles, and click run. And it should only take a few seconds. And there we go. We now have a new layer. So I'm going to turn off our point layer for now. And if I open the attributes table here, it might take a few seconds because there's actually quite a lot of columns here now. And we've got all the country data that the original polygon layer had. But when we get further along, we've now got this point data. We can see there's some 0 and null values. That's fine. They're just countries for which there isn't any data. You can see as we go through, as more countries start to get cases, then we see more of them having values. The reason I get this sudden change here is this is the second set of values that I calculated with the proportions of world cases within each country. If you want to calculate extra attributes like that, then you've got several options. You can either use the raster calculator within QGIS. What I actually did was to play around with the CSV file in Excel beforehand and actually do some calculations in Excel. Obviously, if you're familiar with other software, you could use R, you could use Python, various tools for calculating extra statistics. But for now, as I said, I'm sticking with just the kind of simple overview of how to map it in QGIS. So now we've got our polygon layer with the case data joined to it, we can look at visualizing it. So again, we simply go to Properties, Graduated, and what I'm going to do is again select the last date that I had, which was the 19th of April again. I'm going to stick with the red color amp, and as I said, the natural breaks seems to work quite well. So I'm going to change it to natural breaks and click apply. And there we go. We now have our world map coloured according to the number of cases in each country, and we can see our classes down here. And if we wanted, we could go into layout view, turn that into a proper map. Now, if we want to create a visualization over time, unfortunately, there's not an easy way to do that at the moment, at least not without some extra formatting. There is a time manager plugin within QGIS, but that requires us to have a column with time information, which actually is pretty inefficient when we're looking at a lot of time steps and a lot of attributes like this. So we could reformat it to allow time manager to work. What we basically need would be a row for each country on each day to provide the data, which, as I said, to me seems quite an inefficient way of doing it. On the other hand, if we wanted to take a bit of time, we could easily produce a manual animation. What we can do is actually leave the symbology set with the data from the most recent data, which is obviously going to have the highest values in terms of global cases. And we can simply go back to our first date, set that to our value field and click apply. And we can suddenly see we have very little data because everything's very low. We have China is in white because they're obviously reported cases, but it's relatively low compared to what we have now. USA is shown here probably with at that point 0 cases. And we can then either step day by day through the data, which again is going to have very small changes, or jump forwards several weeks and start to see it kind of develop as more countries report cases. So if we wanted to, we could take the time and actually export a figure for each time step and start to see those colours change, start to see the situation evolve as we move forwards through time. And we can see initially moving in February, not much happening. Probably once we get to past mid-March, we'll start to see a few more changes around the world. There we go. We can now see Europe and the US starting to turn pink as we start to get higher numbers of cases. So there we go. Very quickly and simply, that's how we can map coronavirus data. And as I said, I focused on cases, but you can use exactly the same method. Download the CSV file for deaths, and obviously with a few calculations, you could then work out death rates per country, dividing deaths by cases and that kind of thing, to visualize those as well. And as I said, we can then step forward over time. We can show colors, we can show the point sizes, we could show both. When I first started up, I had it in a different projection. If you want to change the projection, you can simply click down in the corner of the map here, EPSG code, and I changed it to an equal area projection, which is this ETRS 89. So if I click apply there, we can see that just instantly warps the map to the new equal area projection if we want to get more of an idea of kind of areas within each country. But you can obviously pick the map projection that you like the most. So hopefully that's been useful. Hopefully that's shown you how you can start mapping and investigating this data yourself if you want to start making some visualizations and delving carrying out your own analysis into coronavirus case data, deaths, and recovery rates. If you found that useful, please do like and subscribe and keep your eyes peeled for more videos in the near future. Thanks a lot.